Hello everyone. Today let us discuss about refraction through a prism. We will derive the expression for the refractive index of the material of the prism. This is one of the most important derivations of ray optics because this derivation will be useful to solve so many numerical problems also. So let us learn it carefully. Here I have taken a prism ABC. I will show it in detail in the next picture. So here we can see a prism ABC. Now here AB is one surface and AC is another surface. A ray is incident on the surface AB. We call it as face AB. A ray comes from P and touches the prism at Q. Wherever it is incident, we draw a normal. Normal means perpendicular line. QN is the normal to the face AB. Therefore, I is the angle of incidence. That is the angle between incident ray and the normal. Now the ray is going from rarer medium to denser medium. It is going from air to glass. Therefore, the ray bends towards the normal and it goes along QR inside the prism. After that, it suffers another refraction at the surface AC. So, the ray when it goes along QR, it touches the other face AC at R. Therefore, we have drawn another normal NR to the surface AC. To the face AC, we have drawn NR as the normal. Now, the ray bends away from the normal and comes in this path RS because it comes from denser medium to rarer medium. Therefore, this ray bends away from the normal. Now, if you observe, for the first face AB, angle of incidence is I, angle of refraction is R. For the second face AC, angle of incidence is R and angle of refraction is E. Why we took it as E is, E stands for angle of emergence. Now, this is what happening. A ray comes from P and touches the prism at Q, then it is refracted for the first time. It goes along QR, again it touches the second surface AC, second time it is refracted and it goes along RS. Now, if you see, I is greater than R1 because it goes from rarer medium to denser medium. Therefore, angle of incidence is greater than angle of refraction. But at the second surface, E is greater than R2. Why? Because it goes from denser medium to rarer medium. Here E is greater than R2. Okay, so let's continue. Now, in this figure, we see a triangular prism ABC. This figure shows the passage of light through the prism. The angles of incidence and refraction at the first face AB are I and R1. Already I have explained you I and R1. While the angles of incidence, that is from glass to air, at the second face AC is R2 and the angle of refraction or emergence is E. So, the angles of incidence and refraction at the first face AB are I and R1, while the angle of incidence at the second face is R2 and the angle of emergence is E. The angle between the emergent ray RS and the direction of the incident ray PQ is called the angle of deviation and it is denoted by delta. What is this angle of deviation? Suppose if this prism is not present, this ray would have gone straight like this. I'll take you back to the big picture. Suppose if prism is not present, the ray would have gone straight like this along PQ and along T. But because of this prism, the ray suffers 2 times refraction, first time at AB and second time at AC and comes along the path RS. Now, if you extend this ray that is refracted ray RS backside, it touches this original path that is PQT at M. So M is the point of intersection where these two lines meet. Therefore, the angle between the original path and the refracted path, that is called as angle of deviation. Here delta is angle of deviation. Now that is what I have shown here. The angle between the emergent ray RS and the direction of the incident ray PQ is called the angle of deviation and is denoted by delta. Now the quadrilateral AQNR. Let us take the quadrilateral AQNR. Here we have drawn normals, that is QN is perpendicular to AB and NR is perpendicular to AC. That means angle AQN is 90 degrees, angle ARN is also 90 degrees. AQNR is a quadrilateral. So in this quadrilateral, if you see angle Q, that is AQN, and angle ARN, both are 90 degrees. The sum of four angles in a quadrilateral is equal to 360 degrees. Therefore, when Q and R is equal to, that means Q plus R is equal to 180, because 90 plus 90, that is 180, then the remaining two angles A and N, that sum of the two angles A and N is also equal to 180. Therefore, in the quadrilateral AQNR, two of the angles at vertices Q and R are right angles. As I told you, they are normal. Therefore, the sum of the other two angles of the quadrilateral is 180 degrees. Other two means angle A and angle QNR. Angle A plus angle QNR is equal to 180 degrees. Equation number 1. Let us take the triangle QNR. We know the sum of the three angles in a triangle is equal to 180 degrees. Therefore, R1 plus R2 plus angle QNR is equal to 180 degrees. R1 plus R2 plus angle QNR is equal to 180 degrees. Let it be equation number 2. Now compare the equation 1 and 2. If you compare equation 1 and 2, you can see RHS for both of them 180, 180. So you can equate LHS. Once you equate LHS, you get, that is angle A plus angle QNR is equal to R1 plus R2 plus angle QNR. So this is what we get. So then we can cancel QNR both the sides. Then angle A is equal to R1 plus R2. I hope you understood. So we have equated LHS here, LHS here, both of them we have equated. Then once you equate both of them, I'll remove these marks so that you can see clearly what I have written. So once you equate equation 1 and 2, you will get from these equations 1 and 2, angle A plus angle QNR is equal to R1 plus R2 plus angle QNR. Both the sides QNR cancel. Therefore, R1 plus R2 is equal to A. Let it be equation number 3. Then let's continue. Comparing equations 1 and 2, we got R1 plus R2 is equal to A. That is equation number 3. Now let us see what is the total deviation. Total deviation is because of the refraction at two surfaces. One is at the surface AB, another is at the surface AC. Therefore, refraction for the first surface is because of this one, that is deviation because of the first refraction I minus R1. Similarly, deviation because of the second surface, that is E minus R2. Already I told you I is greater than R1, E is greater than R2. Therefore, deviation is the sum of the deviations because of the first surface and because of the second surface. Therefore, the total deviation delta is the sum of the deviations at the two faces, that is delta is equal to I minus R1, that is because of the first surface, and E minus R2, that is because of the second surface. Let it be equation number 4. So let us rewrite it. So let us rewrite how we will write. delta is equal to I minus R1 plus E minus R2, that is I plus E minus R1 plus R2. So that is what we have written here. Delta is equal to I plus E minus R1 plus R2 within bracket. But from here R1 plus R2 is equal to A. So you can substitute here in place of R1 plus R2. If you substitute A, you will get delta is equal to I plus E minus A. Let it be equation number 5. Let it be equation number 5. I'll delete all these marks so that you can see the clear notes. After the video, you can write these notes. It is neatly written. Therefore, so let us continue. Delta is equal to I plus E minus A, which is equation number 5. Thus, the angle of deviation depends on the angle of incidence. Now, clearly angle of deviation depends on angle of incidence. Let's continue. Now, if we draw a graph taking angle of incidence on x-axis and angle of deviation on y-axis, the graph comes exactly in the shape of U. You will also do it in the lab. This is one of the experiments which we have to do in the lab. I have already done this experiment. I have uploaded a video directly when I was doing the experiment. You can see my previous videos. I have done this experiment. Now, a plot between the angle of deviation and the angle of incidence is shown in the following figure. Now, if you observe this graph, for every angle of deviation, we have two angles of incidence. For example, let us take 50. Let us take 50. 50, if you take angle of deviation 50, for that you have two angles of incidence. One is between 20 and 40. Another is greater than 80. So two we have. Similarly, I will take one more example. I will draw from 40 a straight line. This straight line, it touches these 2 points, 2 green points. When I draw like this, it too has 2 points on x-axis. So for every angle of deviation, there are two angles of incidence. That means for two angles of incidence, we get one angle of deviation. But there is an exceptional case. This is the last point. At this last point, there is only one angle of incidence and one angle of deviation. If you observe carefully, this last point, it has only one angle of incidence from x-axis, one angle of deviation from y-axis. Clearly you can see this particular angle where you have only one angle of incidence for one angle of deviation, we call it as angle of minimum deviation. So, in general, any given value of delta except for I is equal to E corresponds to two values of I and hence of E. Okay, so that is what I have explained you here. Now let's proceed. That angle of deviation where you have only one angle of incidence for one angle of deviation, we call it as angle of minimum deviation and we represent it with dm. dm stands for angle of minimum deviation. So the angle at which we have only one angle of incidence for one angle of deviation, we call it as angle of minimum deviation, which is represented by dm. So let's proceed further. Now if you see, at the minimum deviation dm, the refracted ray inside the prism becomes parallel to its base. This is one of the important points to be noted. It is often asked for 1 mark questions also, no? So at minimum deviation, you can clearly see this ray, that is QR inside the prism, it is parallel to the base of the prism BC. QR and BC are parallel to each other only at minimum deviation. At minimum deviation, QR is parallel to BC. At minimum deviation we took as delta is equal to dm. I is equal to E. I is equal to E. At minimum deviation, this angle I is equal to angle E. At minimum deviation, angle I is equal to angle E. Okay, when I is equal to E, R1 is equal to R2. So, I will take you back to the equation number 3. So, here you have equation number 3, R1 plus R2 is equal to A. At minimum deviation, I is equal to E, then R1 is equal to R2 is equal to R. Let us say R. Therefore, R plus R is equal to A from this equation 3. Therefore, 2R is equal to A, then R is equal to A by 2. R is equal to A by 2. Okay. So, I will clear this writing. I will go back to that place. Now, this is what we were seeing. R1 is equal to R2 is equal to R. Then R plus R is equal to A. 2R is equal to A. R is equal to A by 2. Let it be equation number 6. Then, in the same way, equation 5 gives. What is equation number 5? Let's go back. This is equation number 5. Delta is equal to I plus E minus A. But at minimum deviation, we took delta as dm. I is equal to E. That means I plus I since I is equal to E. Since I is equal to E. Therefore, delta is equal to I plus I plus I, then minus A from equation 5, minus A. So, I plus I minus A, dm is equal to from equation 5, because I is equal to E, at minimum deviation, I is equal to E. Therefore, I plus I minus A. Therefore, dm is equal to 2I minus A. dm is equal to minus 2, dm is equal to 2I minus A. Okay, let's go back to our that place, the other slide. Before going, I am deleting this data so that you can see the clear notes. Yes, okay. Here, dm is equal to 2I minus A. Therefore, 2I is equal to, bring A to this side, dm plus A. So, what we have done here, dm is equal to 2I minus A. So, therefore, dm plus A is equal to 2I, or 2I is equal to A plus dm. Therefore, I is equal to A plus dm divided by 2. So, that is what I have written as equation number 7. I is equal to A plus dm by 2. Now, we got the value of R and we got the value of I. And the next work is that nothing but just to substitute these two values of R and I in Snell's law. We all know the Snell's law. Snell's law says that refractive index N21 is equal to sin I by sin R. So, let us take Snell's law, which we all know very well. The refractive index of the prism is N21, that is equal to N2 by N1, which is sin I by sin R. But what is sin I? We got here. Sin I is equal to A plus dm by 2. And what is R? A by 2. I is equal to A plus dm by 2. So, in place of I have substituted A plus dm by 2. In place of R, I have substituted A by 2. So, let us go back. R is equal to A by 2. I is equal to A plus dm by 2. So, I have substituted sin A plus dm by 2 divided by sin A by 2. So, this is the derivation which we want. This is the derivation. So, refractive index of the material of the prism N21 is equal to sin A plus dm by 2 by sin A by 2. Okay. So, this is one of the most important derivations which you have to learn. It may be asked for 3 marks or 4 marks or 5 marks with a numerical. So, learn carefully. So, refractive index of the material of the prism N21 is equal to sin A plus dm by 2 divided by sin A by 2. Then the angles A and dm can be measured experimentally. I have also done one experiment here in the YouTube. You can see that we can measure them. Therefore, equation 8 thus provides a method of determining the diffractive index of the material of the prism. From this equation, you can find the refractive index of the material of the prism. Now, this derivation is over, but sometimes they will ask you to also find angle of minimum deviation. For a thin prism, let's continue. It's a small thing. So now, for a small angle prism, that is a thin prism, dm is also very small. Small prism or thin prism means it is like this, where this angle of the prism is very small. So, in that case, angle of the prism is small, then dm, that is minimum deviation, is also very small. When dm is also small, we can write this equation as sin a plus dm by 2 by sin a by 2. But when theta is small, we can write sin theta is equal to theta. When theta is small in trigonometry, sin theta is equal to theta. That is what we are applying because a is small and dm is also small. Because a is small and dm is also small, what we are doing now is, instead of sin, we will remove this sign and we will write only a plus dm by 2. Here also we will remove this sign, we will write only a by 2, because when theta is small, sin theta is equal to theta. Therefore, n21 is equal to a plus dm by 2 by a by 2. 2 and 2 cancel, we get a plus dm by a. Okay, so a plus dm by a. That is, we can write a plus dm whole divided by a, then a by a plus dm by a, then a and a cancel, 1 plus dm by a. So that is what we got here. n21 is equal to 1 plus dm by a. Okay, so after that, let us take 1 to the other side. I will take 1 to the other side. So what happens now? It is now n21 is equal to 1 plus dm divided by a. Then n21 minus 1 is equal to dm by a. Send a to the right side. A into n21 minus 1 is equal to dm. That is what we got. dm is equal to n21 minus 1 into a. Okay, this is the expression for angle of minimum deviation. This is also one of the important derivations. Sometimes they ask only to find the refractive index of the material of the prism, but sometimes they also ask to find the angle of minimum deviation. That is, dm is equal to n21 minus 1 into a. Better to learn it carefully because it is also a lab experiment, and the examiner of the lab exam may also ask viva questions. So let us have complete knowledge about the theory part, because we can answer anything whatever the examiner asks. So finally we have done two things now today. We have done, that is, refractive index of the material of the prism. n21 is equal to sin a plus dm by 2 by sin a by 2. And another thing, angle of minimum deviation for a thin prism, dm is equal to n21 minus 1 into a. It implies that thin prisms do not deviate the light much. Okay. With this, I can conclude this derivation. All the best. Learn carefully. Okay. We will meet again. Okay. In the next video with one more topic. Okay. Thank you for watching this video. God bless you all. We will meet again in the next video with another new topic. Until then, bye. God bless you all.